Alright, let's go. Number 10. The Great Red Spot. For over 3.5 centuries, astronomers logged the Great Red Spot as a fixed feature of the Jovian atmosphere. Amy Simon at NASA's Goddard Space Flight Center had a routine assignment in the mid-2010s, track the storm's dimensions using Hubble's annual outer planet observations. This was maintenance science. Nothing was supposed to be moving fast. Storms on Earth die in weeks. Rotating fluid vortices, when isolated from continual energy input, dissipate as friction and thermal exchange bleed off their angular momentum. Jupiter's red spot had violated this expectation for as long as humans had been looking at it. The standard assumption was that it drew energy from surrounding jet streams and would persist indefinitely. It is not persisting. Simon and her colleagues published measurements in the Astronomical Journal in 2018 showing the spot has shrunk from roughly 40,000 kilometers across in the late 1800s to under 16,000 kilometers today, with the contraction rate accelerating in the last 20 years. Juno's gravitational data added the depth. The spot extends only 200 to 500 kilometers into the atmosphere, thinner than models required. Every explanation has cracked under scrutiny. The idea that smaller storms were feeding it energy, Voyager and Galileo data showed the mergers weren't sufficient. The idea that jet stream interactions were pumping vorticity. Juno's velocity maps didn't match the prediction. The idea that it was simply a cyclical fluctuation, the historical trend line shows a monotonic decline, not oscillation. Philip Marcus at Berkeley proposed instabilities in the vertical structure. His own 2019 modeling could not reproduce the observed thinning. A storm older than the telescope itself is dying. And no one can explain what is killing it. When it goes, and current trajectories put that inside your lifetime, the largest and oldest storm ever recorded by humans will vanish from the sky, and we will have watched it happen without ever understanding it. Was it ever stable, or have we been watching the long end of something that started dying before we could see? The next disturbance sits deeper, in a chemistry Earth's atmosphere cannot host. Number 9. The Shallow Lightning. Radio astronomers had detected lightning on Jupiter since Voyager 1 in 1979. It was a solved problem. Jovian lightning was assumed to work like ours, deep in water clouds, driven by charge separation between ice crystals and liquid droplets. Shannon Brown and the Juno Microwave Radiometer team were meant to be mapping ammonia distribution in 2016. Lightning was a side product. Terrestrial lightning has a signature. Radio emissions concentrate at low frequencies, below about 10 megahertz, because they originate from long discharge channels in water-based clouds several kilometers thick. Any planetary lightning driven by the same water-ice physics should look similar. That was the prediction going in. The signal came in at 600 megahertz. Brown and colleagues published in Nature in 2018 prevalent lightning spherics at 600 megahertz near Jupiter's poles, reporting flashes at frequencies impossible for standard water cloud discharge. Heidi Becker and her group followed in Nature in 2020, showing the flashes originated only about 25 kilometers below the visible cloud tops in a region far too cold for pure liquid water to exist. Every candidate mechanism failed. Pure water clouds at that altitude, the temperature is roughly minus 88 degrees Celsius. Water is solid. Ammonia-only clouds. Ammonia is a poor conductor and shouldn't discharge that way. Standard mixed-phase electrification, the physics doesn't scale to those pressures. The best surviving explanation involves ammonia acting as antifreeze, allowing liquid water ammonia droplets to exist at temperatures where nothing on Earth stays liquid. Ivana Kolmov's group in 2018 modeled this and found the chemistry works, but no lab has reproduced the discharge behavior. There is lightning inside Jupiter that fires through a chemistry that shouldn't produce lightning, at temperatures where our physics says the storm shouldn't work, in droplets no experiment has yet made stable. If this chemistry is real, it is running continuously through a volume larger than every ocean on Earth, and we still don't know what it does. Above that lightning, at Saturn's pole, there is something even harder to explain. Number 8. The Hexagon. The Voyager 1 and 2 flybys in 1980 and 1981 were meant to give planetary scientists their first close look at Saturn's atmospheric circulation, jet stream widths, cloud band chemistry, storm distributions. Standard atmospheric survey work. When David Godfrey and colleagues started assembling the polar images in the mid-1980s, they noticed something no rotating fluid on any planet had any business producing. Fluid rotating around a pole should form circular banded flow. Every rotating body of gas or liquid on Earth demonstrates this. Hurricanes, laboratory vortices, ocean gyres. Simulations of Saturn's atmosphere from the 1970s all predicted circular polar jets. The mathematics of Rossby waves and jet stream physics has one clean answer for the shape of a stable polar circulation, and that answer is a circle. Saturn's north pole is a hexagon. 6 sides. Sharp corners. Persisting for at least 40 years. Godfrey published the initial identification in Icarus in 1988 based on Voyager data. Cassini imaging from 2006 through 2017 confirmed the hexagon had not drifted, had not degraded, and had not deformed measurably in 3.5 decades. The sides are approximately 13,800 kilometers each, larger than Earth. Winds inside the jet flow at 322 kilometers per hour. Ana Aguiar and colleagues published lab experiments in Icarus in 2010, producing hexagonal flow patterns in a rotating tank with a differential velocity inner boundary, a proof of concept. But the parameters required did not match Saturn's atmosphere. Kunio Sayanagi's group refined the models. The wave number 6 instability the lab produced was transient. Saturn's is not. Every attempt to reproduce persistent hexagonal geometry has required tuning that Saturn's atmosphere does not appear to satisfy. There is a geometric shape locked into the atmosphere of another world that has no known cause, has been there for our entire time observing it, and may have been there for millions of years before we looked. What draws a shape and holds it that long, on a planet that is only gas? Deeper down, in Jupiter's interior, matter itself starts refusing to behave. Number 7. The helium rain. David Stevenson at Caltech and Edwin Salpeter at Cornell were not looking for anything unusual in 1977. Their task was ordinary equation of state work, how do hydrogen and helium mix under Jovian interior pressures. Their paper in the Astrophysical Journal Supplement series that year, The Dynamics and Helium Distribution in Hydrogen-Helium Fluid Planets, was meant to be a foundational calculation, cited a few times, forgotten, at the pressures inside Jupiter, millions of times Earth's atmosphere. Hydrogen and helium were assumed to be miscible. The Sun's helium fraction is roughly 24% by mass. Jupiter formed from the same nebular material. Its atmosphere, unless something strange was happening, should contain the same fraction. The Galileo probe was sent in 1995 partly to confirm this. It was a check-the-box measurement. The probe found only about 20%. Something had removed helium from Jupiter's upper atmosphere. Stevenson and Salpeter's math predicted it. Under specific conditions inside the planet, helium becomes immiscible in liquid metallic hydrogen. It condenses into droplets. And because helium is heavier, the droplets fall. Hugh Wilson and Burkhard Militzer at UX Berkeley published first-principle simulations in Physical Review Letters in 2010 mapping the exact pressure-temperature regime where the phase separation happens, deep inside the planet, tens of thousands of kilometers below the visible cloud tops. Every alternative was ruled out. Preferential loss to space, Jupiter's gravity makes that impossible. Sequestration in a compact core, the timescales don't work. Chemical binding, no reactions at those pressures produce the observed depletion. The only mechanism that survived every check was rain. Liquid helium droplets, forming inside a fluid ocean of metallic hydrogen, descending under gravity toward the planet's interior. Something is raining inside Jupiter that has never been observed anywhere in the accessible universe. The droplets that formed in Stevenson and Salpeter's equations are falling right now, have been falling for 4.5 billion years, and will continue falling long after Earth is gone. You share a solar system with a storm no instrument will ever see. 2 planets further out, the weather turns harder still. Number 6. The Diamond Rain. Marvin Ross at Lawrence Livermore National Laboratory was working on high-pressure equation of state calculations for planetary interiors in 1981. His employer wanted the data for weapons research. He was interested in Uranus and Neptune. A short paper in Nature that year, The Ice Layer in Uranus and Neptune, Diamonds in the Sky, was a side calculation, 4 pages long, buried in the miscellaneous back sections. Uranus and Neptune contain enormous quantities of methane in their mantles. Under the pressure of tens of thousands of Earth atmospheres, at temperatures of several thousand Kelvin, methane decomposes. The carbon has to go somewhere. Standard chemistry says it should form long-chain hydrocarbons, then graphite. Then increasingly ordered carbon phases as pressure rises. That is the textbook answer. Ross's math said diamond. His paper predicted that at approximately 100 gigapascals and 3000 Kelvin, conditions present in the mantles of both ice giants, carbon would crystallize into diamond. For 36 years, no one could test it. The pressures were beyond any experimental facility. Then in 2017, Dominic Krauss and colleagues at SLAC National Accelerator Laboratory used the Linux coherent light source to shock compress polystyrene into the exact regime. They published in Nature Astronomy in September of that year, nanometer-scale diamonds formed within picoseconds of reaching Neptunian conditions. Every alternative had been floated and had died. Amorphous carbon at those pressures, thermodynamically unstable. Metallic carbon phases required temperatures higher than the planetary interior produces. Suspended graphite flakes, the density is wrong, they wouldn't sink cleanly. Diamond was the only phase left that fit both the pressure-temperature diagram and the eventual buoyancy signature. Which means inside Uranus and Neptune right now, diamonds are forming continuously and falling toward the core through a mantle of superheated ionic fluid. The largest may reach centimeters across before they settle. There are 2 planets in your solar system where diamonds fall as weather. You will never see one. But the sky above you contains them. Around Jupiter, something even less predictable is being generated. Number 5. The Irregular Magnetic Field. The Juno spacecraft entered Jupiter orbit in July 2016. Its mission plan was straightforward: map the magnetic field to unprecedented resolution and settle a decades-old question about the dynamo mechanism generating it. Kimberly Moore, then a graduate student at Harvard, was assigned to process the early magnetometer data. The team expected a cleaner version of what Voyager and Galileo had already sketched, a strong, roughly dipolar field with modest higher-order components. The standard planetary dynamo model produces a field with clear north-south symmetry. Earth has this. Saturn has it to a striking degree. Its magnetic axis is aligned within a fraction of a degree of its rotation axis. All prior data suggested Jupiter should show the same pattern, just stronger. Every textbook diagram of Jovian magnetism showed a tidy dipole with a modest tilt. The data showed a field that looked unfinished. Moore and colleagues published in Nature in 2018, a complex dynamo inferred from the hemispheric dichotomy of Jupiter's magnetic field. The northern hemisphere contained a narrow, intense flux patch. The equator contained a large negative anomaly they nicknamed the Great Blue Spot. The southern hemisphere was comparatively bland. No planetary dynamo model in the literature produced this. The suggested explanations were tested and each failed. A dilute core mixing with metallic hydrogen, Ravet-Helid's group modeled it. The geometry didn't match. Multiple dynamo layers operating at different depths could produce dichotomy, but not the specific pattern. Unresolved surface features from insufficient orbit coverage, subsequent orbits confirmed the anomalies were real and stable. The current best guess is that Jupiter's dynamo is stratified, with different regions of the interior generating different components of the field. No one has published a working model. You live inside the magnetic field of your own planet. It shields you from cosmic radiation. Jupiter's field is roughly 14 times stronger than Earth's and shaped by physics no one has written down. Whatever is happening inside that planet to produce it is not covered by any equation we have. and whatever powers it is generating heat, we cannot account for either. Number 4. The excess heat. Frank Lowe at the University of Arizona in the 1960s was measuring infrared emission from the outer planets. This was calibration work, established the thermal budgets, refined the planetary temperature models. Lowe and colleagues, along with Douglas Oman, produced measurements through the late 1960s that were supposed to be simple energy accounting, but the numbers wouldn't balance. A planet receives solar energy. It re-radiates that energy as infrared. The books have to close. For Earth, they close. For Mars, they close. Jupiter, at 5 times the Earth-Sun distance, should have been radiating a modest amount of thermal energy corresponding to the sunlight it absorbs. That was the prediction. It was radiating almost twice as much. The measured ratio settled at approximately 1.67. Jupiter emits roughly 1.67 times the energy it receives from the Sun. Hanel and colleagues used Voyager infrared data to lock the number in during their 1981 paper in the Journal of Geophysical Research. Andrew Ingersoll at Caltech confirmed and refined the measurement through the 1970s. It has been checked by several independent methods. Every explanation has partial success and full failure. Kelvin-Helmholtz contraction, the planet slowly shrinking under gravity, releasing potential energy as heat, accounts for a substantial fraction. But not enough. Ongoing helium sedimentation from the phase separation in Entry 7 plausibly explains more, but the math is loose. Primordial heat from formation. The planet is old enough that this contribution should be nearly exhausted. Radioactive decay in the interior, the calculated inventory is too small by orders of magnitude. Add every source together and there are still corners of the energy budget no one has closed. There is an unaccounted power source inside Jupiter whose magnitude dwarfs anything humans have ever built. It has been running for 4.5 billion years. No one has identified all of it. Every night the sky above you contains a furnace we cannot fully explain, quietly outperforming a star's warmth with something that isn't a star. Beneath it, the substance doing the burning is something Earth has barely made. Number 3. The metallic hydrogen ocean. Eugene Wigner and H.B. Huntington at Princeton published a paper in the Journal of Chemical Physics in 1935 titled On the Possibility of a Metallic Modification of Hydrogen. They were doing solid-state theory. It was pure quantum mechanics on paper. Could you, in principle, squeeze hydrogen hard enough that its electrons delocalized and it started behaving like a metal? Their answer was yes, at extreme pressures. They had no expectation this would ever be relevant to anything real. Standard hydrogen, the gas in stars, in laboratory tanks, in the outer atmosphere of Jupiter, is molecular. 2 atoms bound, non-conducting, transparent. Everything you know about hydrogen assumes this state. At the pressures accessible in labs through the 20th century, hydrogen stayed molecular. Jupiter's interior does not stay molecular. Approximately 13,000 kilometers below Jupiter's visible clouds, the pressure crosses roughly 1 million bar. At that boundary, Wigner and Huntington's prediction activates. Molecular hydrogen dissociates, and the electrons delocalize. The result is a liquid metal, electrically conducting, opaque, dense. Ranga Dias and Isaac Silvera at Harvard reported in Science in 2017 that they had created a tiny sample in a diamond anvil cell for the first time in laboratory history. Their result has been disputed. The Jupiter ocean, meanwhile, is not disputed. Every alternative explanation for Jupiter's interior structure has failed. A solid rock and ice core with a purely molecular hydrogen envelope inconsistent with the observed magnetic field strength. A gradual transition without a distinct metallic layer, inconsistent with the gravitational moments Juno measured. A fully mixed hydrogen-helium interior, inconsistent with the observed helium depletion in the upper atmosphere. The metallic hydrogen ocean is the only model that survives. Beneath the clouds of Jupiter is an ocean of a substance humans have barely managed to make a speck of, existing in volumes larger than the entire Earth, generating the strongest planetary magnetic field in the solar system. The largest ocean in the solar system is made of something Earth chemistry cannot produce, and it wraps around a center that isn't shaped like anyone predicted. Number 2. The fuzzy core. Tristan Guillot at the Kitty d'Azur Observatory had been modeling Jupiter's interior structure for 2 decades. When Juno's gravity measurements started arriving in 2016 and 2017, his team's job was to fit them. Guillot expected to refine numbers, tighten error bars, publish an update. The models he had built assumed Jupiter had a compact, rocky, icy core surrounded by a hydrogen-helium envelope. That was consensus. Every gas giant formation model requires a core. Standard core accretion theory says a heavy element seed of roughly 10 Earth masses attracts hydrogen and helium during formation. The seed remains. It should be small, dense, and sharply bounded, a definite object at the planet's center. This model made Jupiter. It made Saturn. It made every giant planet catalog we teach. Juno's gravity data said there is no such object. Guillot and colleagues, along with Yamila Miguel and Ravid Held, published across Nature and Astronomy and Astrophysics between 2017 and 2019, showing that Jupiter's central region is diffuse, heavy elements smeared through roughly half of the planet's radius rather than concentrated in a small, dense core. The core is not gone. It is dissolved. Jupiter's center is a gradient, not a boundary. Every proposed explanation failed to fully close. A giant impact early in Jupiter's history that shattered the original core. Shang-Fei Liu and colleagues proposed this in Nature in 2019, but the required impact energetics are extreme, and the initial conditions finely tuned. Convective erosion mixing core material into the envelope, the mixing rate would have to be higher than models predict, running against the density gradient. A different formation mechanism that never produced a compact core, inconsistent with the heavy element abundance patterns, which means the largest planet in your solar system did not form the way textbooks describe. Whatever process built it either destroyed its own core or never made one. And no one knows which. The planet you were taught to picture, a gas envelope wrapped around a rocky heart, is not a real object. It never was. The final entry is the one that changes what the planet might contain. Number 1. The possibility inside the cloud layer. Carl Sagan and Edwin Salpeter published a paper in the Astrophysical Journal Supplement series in 1976 titled Particles, Environments, and Possible Ecologies in the Jovian Atmosphere. Sagan was famous. Salpeter was one of the great theoretical astrophysicists of his generation. They were running through what physics permitted rather than what anyone was searching for. The result of the exercise was uncomfortable. The consensus view of Jupiter was, and mostly still is, that it is uninhabitable. Too cold on top, too hot below, no solid surface, no liquid water reservoir at any pressure layer we could reach. The consensus view left out one region. At approximately 1 bar of atmospheric pressure inside Jupiter's cloud deck, the temperature crosses through the range where liquid water can exist. It is a narrow band, but it is real. In this band, the atmosphere contains water vapor, ammonia, methane, hydrogen sulfide, and traces of complex organics. Sagan and Salpeter worked out the physics of buoyant organisms, floaters, they called them, hydrogen-filled biological balloons that could maintain neutral buoyancy in the temperate layer, sinkers that dropped and rose in reproductive cycles, hunters that fed on floaters. They were not claiming any of this existed. They were showing it was not forbidden. Every attempt to close the possibility has failed. Insufficient chemical energy, but the atmospheric chemistry is far from equilibrium, exactly the disequilibrium biology thrives on. No stable substrate, floaters solve this. UV sterilization, the upper cloud layers block it before it reaches the temperate zone. The Galileo probe descending in 1995 sampled parts of the atmosphere and found the chemistry richer, not poorer, than expected. Sarah Seeger at MIT has extended the framework to gas giant biospheres more broadly. No result has ruled the possibility out. The largest object between you and the outer solar system contains a region where life is not forbidden by physics. It may be empty. It may not. The one place we assumed was too hostile to check is the one place no one has ruled out. Have you looked at the sky at night and known which point of light might already be inhabited? None of these 10 anomalies live at the frontier of physics. Every one of them sits in the middle of our best-tested theories: thermodynamics, magnetohydrodynamics, quantum mechanics, planetary formation. The universe is not being coy at the edges. It is being defiant at the center. The gas giants are not exotic laboratories doing exotic things. They are ordinary objects, formed by ordinary processes that turned out to contain phenomena we still cannot describe. The horizon of what we do not know is not far away. It is above your head every clear night. If you want to see more videos like this, click the video on screen now.